All right, so today we're here at the Added Progress Show with the guys at EPS. We're here with Joe Hess right now. We're going to go over what we're standing in. Joe's going to tell us everything we need to know about what we're in, how this is built, and all that fun stuff. So, Joe, I want to know, what is this? What's this building made out of? This is a SIP panel building?
This is our show building here at Ag Progress Farm Show Days. And it's a structural insulated panel connected to a post frame building. So we have a 24 by 40 structural insulated panel building. We call it solid core. It's built with this technology. It's actually an 8-inch thick panel, so it's 7 1/4 inches of foam, 7/16 OSB on the exterior, 3/4 inch on the interior.
Okay.
Because we have that 3/4 inch on the interior, we have a thermal break, so we don't have to do another facing on it to meet code. We've already met code by having the 3/4 inch on the interior. So if a farmer wants to paint this, a farmer wants to put steel on it, he can do whatever he wants. You can sheet rock it. If you're going to make this a cabin, you can sheet rock it, or you can put pine siding on it on the inside.
So how do these things interlock together?
Okay, it's pretty simple. You know, we start off at the base. We have a treated plate we put on top of the concrete.
Yep.
We bolt it into the concrete, and then once this is attached, we put the panel on. Okay, if I can get it back in there. We put it on, and then we nail this first panel on 6 inches on center with an 8 penny nail into that plate.
Okay.
So now this is adhered to the plate, and the plate's adhered to the concrete. So then we put the side panels on it, and we do the same procedure. It's onto the plate, we nail it, and then we put the two together, and we drive a timber screw in from here into this piece of plate, which is attached to this panel.
All the way through to the core.
All the way through to the core. So these two panels are interlocked and basically creating a good solid corner.
Yeah.
Once we have that, and it's level, square, and plumb here, level, square, and plumb here, boy, the rest of the building procedure is a piece of cake. You start in the corner and work your way out both ways. It goes up really fast.
And so you'd have like a 2x4 slipped in here.
Yep.
And it just interlocks.
This is going to be a 4-foot panel.
Yeah.
So it's going to come out from the corner 4 feet. It's going to have these two grooves in it. A 2x4 would slip in here. It would be half in this panel and half in the next panel. And when you slide the next panel on, it gets locked together with this 2x4 on both sides.
All right, and then you just fasten
before you
them all
put
together.
these in, of course, you're putting some sealant in here.
Yep.
That's like a sealant and an adhesive.
Okay.
So this thing is like,
you're making it airtight.
when it's all finished, it's airtight. It's one complete unit. This whole building basically is one complete solid core panel.
Yeah. Let's take a look at the vaulted ceiling here.
Well, some of the panels are about 8 foot wide on the ceiling. So the distance from here to here, that seam is 8 feet.
So that's about like an 8 by 20 foot panel.
Yep.
Which is able to give you that vaulted effect, and you guys would be able to supply those big beams, right?
We do the beams.
Yeah, they come in the package deal. So you'd be able to do like fake beams across, all that stuff, and still have, you don't have to have collar ties because this is good enough.
The panel itself is actually acting as the collar tie so the walls don't spread on you.
Yeah.
So it's an amazingly strong, again, it's seamed at the top, similar to this, and with the timber screws from the top down, and it's screwed in adhesive up here.
Yeah.
So you'd be hard pressed to get the thing apart.
And I noticed you got that up there. Now, that's not structural, although it is helping keep the building together. You don't need that there.
No.
You have this whole open space to do whatever you want inside here. You don't have to have any walls, load-bearing walls, right?
A lot of our customers use this particular design that we're in as a cabin.
Yeah.
So, say this is facing your waterfront site, or you're looking out over a hill for a view, you can bring this deck out halfway, 3/4 of the way, and still have a vaulted area and have bedrooms up above.
Yeah.
Or you can do away with that and just have it completely vaulted. So whatever suits your needs is what we want to do.
Yeah, definitely an awesome concept. I want to talk over here about the different options that you can get
Okay.
on the panels themselves. It doesn't have to just come with, you know, the blank OSB. It looks like you can get FRP, textured FRP, aluminum. It'll come with drywall on them already?
No, we won't put the drywall on it. I think we're just trying to show you the different options. A lot of people, and we've had a lot of people do hunting cabs, and what they'll do is just basically polyurethane this panel so it doesn't get stained or anything going forward. Polyurethane, it looks really sharp, it brings out the brightness of the wood. People like that wood look. Other people, like I said, would put tongue and groove pine boards on it. A lot of people just paint it, whether, I don't know if we do a lot of red paint on it, but you know.
It's just an example,
It's just an example of it. We'll do a lot with white, though. They like the white to brightness. You know, sheetrock, you might do part sheetrock, you might do part wood.
And then the aluminum would be like, let's say you're doing a cold storage building, something like that.
Exactly.
Yeah, you get that, comes on there, and when you put it up, it's already finished on the inside, essentially.
We do wash bays with the FRP. We do coolers with the FRP. We do dairy parlors where you're going to wash it down all the time with the FRP. You want to do an aluminum, if you're going to have some hard chemicals on it, we can get a facing on this that, like meat processing facilities, they take a lot of harsh chemicals, so we'll match up your paint systems. There's some really solid paints in there that are almost impervious to acids. So we'll use that in places where you really have to wash it down. Like this, that, and this all meet USDA standards if you're going to do a meat packing facility or some kind of thing that has to meet USDA standards.
And I know also you can get finished plywood on the inside of them as well. So like you're saying, to polyurethane, I know that I've seen a building that's got a vaulted ceiling like this with beautiful, you know, finished plywood. You know, you showed me that one building,
we have
that is awesome.
We have some different looks, some things we can offer to you. We do a lot of, actually, whenever we laminate the FRP, the NRP, or the aluminum to this board, we change the OSB to plywood because these products laminate to plywood a lot better. So we can change it to plywood. OSB is just our standard. So
that would be nice because it's coming pretty much finished. You're saving, as we always say, trips around the house. Trade's doing a bunch of work. You know, it's just saving on labor, saving on time. Your building's up faster than it would be traditional stick frame.
Tons faster. You're putting up a 4-foot section every couple minutes, and that section has an outside facing, an inside facing, and all the insulation along with the wire chases. I didn't mention that, but we typically do wire chases 18 and 44 off the floor, horizontally around the building.
Those are holes drilled in the foam.
Those are
so
holes
you can
drilled
run your wires.
foam, so you can put your wire and string it through the home anywhere, or the cabin or the shop, anywhere you want to do it.
Oh, okay. Yeah, that's awesome. What type of foam? This is closed cell foam, open cell foam?
It's closed cell foam, expanded polystyrene, EPS. Is the code name for it. It doesn't degrade over time like some of the other foams do. It's impervious to water. It needs an ignition source to burn. So if you just put a match on this, it would melt back a little bit, but it's not going to burn. It's actually going to stop. We've actually seen some instances, because the building is so airtight, where a kitchen has had a grease fire and it's basically sucked the oxygen out and stopped the fire. So the fire didn't spread.
Wow.
So
that's pretty impressive. Yeah, being so airtight.
Yes.
And that's what it's all about.
People think it's hard or it's not good to keep your house airtight, but actually the code calls for an air exchange unit regardless. They want your houses to be airtight. They want you to meet 3 air exchanges per hour in New York State. And a lot of homes don't do that. I know the old 1800s farmhouse that we lived in did not even come close to maybe 10 air exchanges per hour. It was always air flowing through it. Some people think it's good, but you know, like here we're on a busy road and there's car exhaust fumes and everything. Do you want that in your house? I don't think so. So you know, do a solid core building, keep it out. If you're near a highway, you're near an airport, great.
Being able to control, you know, the condition of your space is definitely important.
You control that. You put your air exchange unit in and bring clean air in and take other air out. The other thing you didn't talk about was sound. And I mentioned it when I said airport. If you're near an airport, you're near a busy road, that sound does not penetrate very well through this wall.
Yeah, I could see it. I mean, you're essentially in a giant cooler, you know?
You are.
Yeah.
If I were to shut these doors and close the windows, it would be very...
Yeah, I know, with all the noise we got going on here, you know, tractors and trucks, all that stuff going by.
It'd be really nice if I could do that, but I need to let people come in.
Yeah, exactly. We need people to see this awesome building, you know? Yeah, and so what are the R values that you can get with these panels? Do you know off the top of your head?
I do. And if you go with a 4-inch panel, which we don't use a lot, sometimes in garages, you're going to be in an R18.
Okay.
Our typical, like for a housing panel, is going to be a 6-inch wall, which would get you an R26, which exceeds the energy code needed for your house by a few. And then if you went to this, it's an 8-inch panel, it's going to be an R33.
Okay.
So we can go all the way up to R50 some with our roof panels.
Okay. So that's definitely when I say that you know, you're saving trips around the house with trades. You know, that's saving having the installation guy come and essentially spray foam the entire house. Once the panels are up, you're almost pretty much airtight, insulated, and ready to start finishing the interior, you know, after your electric and all that's ran.
Yeah. Put your hand on the foam. What do you feel?
Body temperature.
Isn't it warm?
Yeah.
It feels warm.
Yeah.
That warmth is actually your body heat getting resonated back to you.
That's funny because I just said body temperature.
So
yeah.
Can you imagine being in this house where all your body heat, your animals, your pets, everything in your house that's warm is radiating back to you. So you're not losing heat, you're actually gaining it by
just being inside of it.
Inside your house.
I mean, you could even do like a radiant heat floor, and
I have
that'd be
it
enough
in my
to
addition.
just heat everything up, you know, and everything is interlocked. It's not easy to do that without taping and making sure everything is sealed on every corner of a traditional house.
Well, I mentioned that 3 air exchanges per hour, and regular stick frame builders really struggle to get that 3. They have to go through some different measures. They're caulking seams. They're doing a lot of other things. They may spray foam an inch or two and then put their fiberglass insulation in, and they caulk before they put their trim boards on. They caulk all the corners and everything around every door. They're going to caulk before they put their trim on. Yeah. Just so they can make that three air exchanges per hour. Yeah. We had a builder hit 2 air exchanges per hour with a SIP panel, and he said, "You're way off, you're crazy, something's wrong." He went down in the basement, he had 2 awning windows open in the basement. He closed those and he hit 0.2.
Wow, really?
0.2 air exchanges per hour. So if we're not in the 1 or point something, just with no extraordinary measures, just putting up the SIP, I'm going to be real disappointed.
Yeah. So you're saving time again on sealing every single hole.
Exactly.
You know, little room for error.
It's already sealed. One of the first things I learned from one of my builders was he walked over and there was an electrical outlet, and he said, "Has your wife ever said, 'Honey, come over here, feel this. I was plugging something in and there's air coming through here'?" Yeah. And she said, "Oh, I made him put those little covers on." He goes, "Yeah, no matter what I've done," he says, "I put the little foam covers underneath the outlets." And he goes, "I could never get the air to stop coming through." Yeah. He goes, "You'll never have that on a SIP." No. There's no air coming through those wire chases. He said, "I will never put those foam covers on again." Yeah. The mezzanine is a pretty simple floor system. There's a lot of different ways to build it. In this particular case, we just wanted a big beam across the front, and our floor trusses run the short distance. Yeah. Which is, I think we ended up with a 10-foot floor system up there. There's nothing says we couldn't have done 15 or 20 feet if we wanted to. Okay. And those would come in the building package from you guys? They would come in the building package. Yeah. It's engineered into the building package. Like this beam over here, because it's such a solid beam and it's carrying a lot of weight, we actually have a 3-ply 2x6 buried in this wall. Our engineering team did that, figured out the loadings that it needed to have based on the load that's going to be up on that floor. And
Oh, so where that beam meets the wall here, that's reinforced then, huh?
Yeah, this wall is reinforced right here. Where the other places you saw, you had a 2x4 on the inside and 2x4 on the outside.
Yeah.
Here you have 3 2x6s built into this wall.
Oh, okay.
To carry that load.
Yeah, yeah.
Just like you have on the main beam up there. On the main beam, I think there's 4 2x6s built into that wall at this end and then back at this end. So our engineering team takes care of all that load and code, takes that liability off of you and the worry.
Yeah.
I mean, when you get it, you know that it's engineered and engineered properly, where if you just went out and bought panels and started putting them up yourself, you're hoping you got it right. This way we know we have it right. We know we have, this building is designed properly by
the people that know what they're doing.
Packages.
Yeah. That's awesome. All right, Joe. Well, I appreciate it.
All right.
Thank you for the little tour here and helping us out.
Thanks for coming by.
Yep, no problem. If you'd like to know more about EPS buildings and SIPS and post frames, you can visit PCSstructures.com in the link in the description below, or you can visit EPS Buildings as well to get more information and get in contact with somebody that can help you out. We can also help them out, but